Okay. Okay. Hello, everyone, and welcome to this talk on this great conference, J Champions. Let's play first a video presenting the conference.
Good morning. I'm Jennifer Nicholson with Oracle, and I want to welcome you to the J Champions Conference, which is organized by Java Champions with all Java Champion speakers. Over 4 days of sessions on January 13th and 14th and 18th and 19th, you will hear from 28 different Java Champions. So who are these Java Champions? Well, they are a select group of over 300 technical luminaries who are leaders in the Java community. You can find a list of Java Champions and learn more about the award at developer.oracle.com/Java Champions. So thank you for being a part of the first J Champions Conference and for your partnership in making Java the #1 programming language and development platform in the world as we continue to celebrate its 25th anniversary. Now grab your favorite beverage, get comfortable, and enjoy one or all of these 24 different informative sessions. Thank you.
Okay, so let's go for it. So we are here to attend a great presentation from Elder Moraes about Java and containers. So the best practices when you put your Java application in a container, and considering those tips that you would have known before, and now you will be attending to Elder to know them. What about Elder? Well, Elder is an author of the Jakarta EE Cookbook. Also is board member of the So Java, Java User Group in Brazil, and also developer advocate at Red Hat. So I don't want to steal more the stage. So Elder, the stage is yours.
Hey, Jonathan. Thank you, my friend. And thank you very much for you who are here today listening to this session. Thank you to this session. I'm very happy to be here in the first Java Champions event, for first Java Champions conference. And thank you very much. So this is, I hope, will be a very useful morning. At least for me, it's morning. I know some people from Europe, it's already afternoon, but for me, it's morning. And let me share my slides here. So I hope you are seeing my slides. Please, Jonathan, if you can't see, let me know. But this is my session, Java and containers, what I wish I knew before I use it. Well, when I first heard about Java and containers, and especially about containers back on 2014, 15, what a picture on my mind was something like this. Everything well organized, everything just working, all the cranes doing their job, all being well orchestrated. But when I really started using containers, and when I really started using containers, especially with Java, my first experiences was just like this, okay? Not so organized, not working so well, not so well orchestrated. That's where I realized that I really need to study more and know more and really know what I was doing, what I'm doing right now. So based on that experience throughout these years, I made this session for you, and I hope it's useful for you so you can avoid some mistakes that I did, a lot of people did. And that's not the whole experience here because it's a lot of years, but everything that I was able to put in 1 hour, I will share with you right now. Before going ahead, let me just share a little bit about me. So my name is Elder Moraes. I live here in Brazil. I'm a Java champion, of course, and a developer advocate at Red Hat, and a board member of Java, as Jonathan just said. And my mission here is to help you, developer, to build and deliver applications so you can work and have success on great projects. Here's my mailing list. I hope there are some people on the chat right now who came from my mailing list because I share this event on my mailing list. So you feel like to have some contents about Java containers, microservers, Kubernetes. I'm sharing on weekly basis something on my mailing list, so you can join on this QR code or URL. All right. Okay. So there are some common issues when we talk about using Java and containers, combine both of those technologies. And I will cover 4 topics here today with you. The first one is the long build time. Okay, so when you are building images, if you don't care about it, you will take longer than you would need if you take some good practices. A lot of topic really important is image size, because if you don't take care as well, you're gonna take huge image size and something because you just didn't pay attention to some really simple stuff. Another stuff is hard maintainability, because sometimes we forget that when we build, for example, a Docker file, that Docker file is a code. And as whatever code that you create, you need to maintain that code. Okay, so you are supposed to make your life and life of others easier by creating your Docker files in a proper way. And the last part of this session is resource allocation, when we are going to talk about memory, CPU, and other stuff being managed inside containers when using with Java. Don't 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 mind about taking pictures, taking notes, because everything that I'm going to share right now, it's on my GitHub on this repository, and it's already available. Okay, so you can go there and just see the slides, see the code, see whatever. So be comfortable, pay attention, and in the end of the session, I will answer some questions. Okay. And the first topic that I'm going to cover here is how to avoid long build time. All right. And I'm going to share my terminal here because will be a very practical session. Let me just, okay. So let's start with number 1. And when we talk about how to avoid long build time, basically we are talking about using the best use of caching, okay? Because when you build a container image, the engine that you are using will beat some caches, and I will explain a little bit more. And you should take some practices to make it easier and make it better. So show my code here, just, yes. Great. So first one. Okay. Not usually, but sometimes when you build a Docker file, you build like this. Okay, so from and copy some files and run some system updates and your CMD. All right. So let's try to run this, to build this image here. Okay. So it will run some stuff here. It was in, okay, that's okay. What I'm going to show you right now, it's some ways, some practice to make easier to use the cache. And in this case, what we are doing here that we was not supposed to do, and it will start doing a lot of this first part. You will see that some examples will take a little bit long. Please don't don't get angry. It's necessary so I can show you what advantages and you can take by just make a simple changes on your code. Okay, and in this case here, we'll take like 1 minute maybe to build this image, and I'm show you how can you can do it by taking like seconds and even less. Okay, what's the main problem here? And I will make this stuff being updated and I will show you the code. The problem here is I am copying my uh, the files of my application before running these updates here. And what's the problem with that? The problem is this part doesn't change a lot, but this part change frequently. Every single time that you will build a new image of your application is basically because you have a new version of your application. And what's the problem with that? Each line of this Docker file will, the Docker engine that is creating this image will create a cache for this line, a cache for this line, a cache for this line, for this line, and for this line. Okay? And let me see. Okay, so took like 1 minute and 44 seconds. Okay? What's the problem here? When I do this, and okay, so if I try, let me show you. If I try to build this image right now, it's boom, instantaneously, because anything changed. Okay, so everything was built using cache. Let me go here. Using cache, using cache, using cache, using cache, using cache, because anything changed. If I go here and package this application again, okay, it's a Quartz application. I will package this application. It's okay, it's fast, okay, good. If I go here and try to build this image again, because I have changed these lines here, the cache of this line is broken, and it will break the cache of the whole Docker file. So it will run this code again. But I didn't change anything here. Okay, but you broke the cache here, and it will break the cache of your whole Docker file. So what you should do instead, just change the orders here. Okay, I will build this image. It will take some time again, but you will get the point once it's done. Okay, so we'll let it, because the whole principle here is what change less frequently you put in the first parts of your Docker file. What changes more frequently you put on the last part of your Docker file. And your application usually will be always the last part, because everything before your application will change eventually. Okay. By doing this, instead of taking like 1 minute, almost 2 minutes here to build this application, I will show you that you can, every single time that you build a new version of your application, you will be able to have a new image by taking less than 1 second. Okay, so it's taking here. Okay, I will let it run. Let me just see my slides here to make sure that I will not skip anything. Okay, good. So let's go to terminal. It's almost done. Because it's already take like 1 minute, and I'm still doing a live stream right now that takes even more process of the machine, so take a little longer. So it's finishing. So as it's building a new cache again, so it took like 1 minute and 27 seconds. Okay, but now this Docker file, it's better than the last one. Okay, so I just changed the orders of my comments. So I will just package the application again. Let me make a little bigger. Okay. So let's just package the application again, so I can force to break the cache of the application inside the Docker file. And let's try to build the image again. Okay, so clear here. Even with a new version of the application now, my build time came from 1 minute and 30 seconds, 40 seconds, down to 1 second. Okay, it's worth it? I think it is, because imagine that you put this application inside a CI/CD, okay, and you have dozens of the application being built and being delivered every single day. Instead of taking a build time of 2 minutes, you have of 1 second. yeah, I believe it's worth it. Okay, so this is our first improvement that you could do on your Docker files right now. Okay, if you have a Docker file, you could do it right now. The second, well, let's get this example of something that is better, and let's make it better. Okay, so I have this version. Okay, so right now I have the updates of the system being done before the copying of this my application. How can we improve it? All right. What's the problem here? Okay, the problem here is that I'm copying my application using star. And what's the problem with that? Let me show you. I will go here to this guy and I will create a file, champions runner.jar. Okay, so I didn't package my application again. I simply put a file by mistake, okay, inside the target folder. But here on my copy, inside my Docker file, I'm copying using star. Okay, so what I'm doing right now is try to build it again. So using cache, didn't use the cache. Okay, this guy here was able to use the cache, but this guy not. So, and I broke the cache of the whole, the rest of the file. Okay, but it's just a one file. Okay, but if you could save milliseconds, 1 second on every single build and have dozens of build, it's still worth it. So instead of doing this, you should do this. Okay, don't use stars to copy your application. Copy the real file. Okay, I will copy this file, not anything other than this file. So I will create this new version of my image. So I will, okay, and I will let me package this guy again just to really make sure. As it is fast right now, I can even try a lot of stuff because it will not take so much time from me. So we'll just try this image again. 1 second, and I will put that file by mistake again. And let's build this image again. Boom. Okay, so I'm still using the cache because even that I put something by mistake inside that folder, as I'm really focusing on that file that I would like to copy, I'm safe. Okay, I will not have any problem with that. Good. So I have now my improved Docker file, and let's do a last step of improvement. And the last step is, okay, now I have this guy here, everything being copied, okay, but I still have one point of improvement. And the point is this point here. And right now we need to build the image again, but I will let you know why I'm doing this. Okay, so what we are doing here, we are running apt-get update, and we are running apt-get install, opjdk, ssh, vim. Okay, what should we do instead? We should use what we call group units. Okay, so I'm basically creating here one group unit of caching. So this update and this install and the install for this guy and this guy and this guy will be a single caching on my Docker file. So I'm making the life of my container engine easier to manage that much of caching, because this stuff, to be honest, will not change a lot. Okay, sometimes can change, but not change so frequently. So why not just put all of them inside of the same unit of caching? Okay, so I will show you my layers when it's done. So instead of having how much 1, 2, 3, 4, 5 layers, I'm gonna have 1, 2, 3, 4 layers. We'll save one layer of caching, but one layer of mostly of the content that I have inside this container is basically on these three lines here. So, okay, 1 minute and 29 seconds. And right now, if I just do it again, I will show you the cache. Right now, I have just one cache here for this guy here using cache. Okay, so apt-get install, apt-jdk, ssh. Okay, so now I have I improved. I started from, and this Docker file will be the same throughout the end of the session. Okay, I will keep improving it and improving it and improving it. So we have not a state of the art because I don't believe that it exists, but I will have a better Docker file. Okay, better to build, a better to maintain, and better in terms of size. That will be our next part. Okay, so let's talk about sizing. But let me share my slides one last time just to make a quick review here. So we talk about order when talking about caching. We talk about being specific. So copy the file and not using stars and so on. And group units. Okay, so whatever you can group inside your Docker file, please do it, and you have a better caching for your image. Okay, so second part, how to get rid of huge image sizes. That's one of the biggest issues when using Java with containers. So let's work on it. Let me open the first guy here, and I will go to this guy here and change folder. Okay, good. For the first case, we're gonna start from where we stop it. So let me create a new image. Okay, it's easier now because it's fast. Okay, so we have the order is okay. We are being specific, and we have group units. Okay, how can we prove it? And here we have two things very important. I will let it to running so I can explain what's is being done here. Okay, this Docker file here. What we are doing? We are installing OpenJDK, SSH, and VIM. And I ask you, why would I need an SSH and a VIM inside a container? Oh, sometimes I need to debug, sometimes I need to do this and that. Okay, when you need it, you go ahead and install it. But if that's something that you don't use every single time that that container is used, please don't install it, because whatever you are installing in this image, it will take some space. Okay, so it will increase the size of your image. So first, remove what you don't need. And another tip, on when we are using apt-get, we have a magical flag here called no install recommends. What this flag do is, well, don't install recommendations, okay? Because the default behavior of apt-get is once you are installing some packaging, it will install the recommendations. Okay, but if they are recommendations, they are not required, and if they are not required, you should not install it on your container because it will increase the size of your container. Let me check here. Okay, so 1 minute and 5 seconds. Let's compare the sizes. Okay, so basic size one don't is 662 megabytes, and the size do is 500 megabytes. So basically, we came from 662 to 500, 160 megabytes just by removing what we removed, SSH, VIM, and we didn't install recommendations. Okay, that's really worth it. Okay, again, you are not working to have one container, two containers. You are working to have hundreds of containers, maybe thousands of containers, maybe. So every megabyte counts. Okay, so go ahead. Let's keep improving it. We will start from this guy here. Okay, so just like the last one. And how can we prove this guy here? Okay, so I will keep it running and then I will explain it. Okay, it will take some time. What basically I did here. So, okay, right now I'm not installing the recommendations. I'm not installing SSH, VIM, and whatever I don't need. How can I prove it? Okay, just go ahead and remove the cache of your package manager. Okay, because here, what's my package manager here? It's apt-get. Okay, when apt-get install some stuff, update some stuff, it will create a cache inside Linux. And this guy here, basically, the cache is inside this folder. You will not need this cache because it's not a machine that you are maintaining and so on. It's a container, okay? It's useless, this kind of caching here. So just, and not, I'm not talking about the cache of the container, okay? The cache that the container engine is building. I'm talking about the Linux, the apt-get caching inside Linux, okay? So just remove it, okay? You don't need this. Let me check here. Okay, it's already building the image. Okay, let's compare. Docker images. Okay, the AC size is 2 don't, it's 504 megabytes, and the do just removing the cache is 488 megabytes. Basically 14, 15, yeah, something like this. Okay, the downsize that just by removing the cache, something that you will not, whatever you don't need, don't let it be inside the container. Okay, this was the second part of the session about sizing. So let's jump to the slides just to summarize here. So mind about unnecessary dependencies. So just remove SSH VIM, use no install recommends or other option inside the package manager that you are using. Eliminate package manager caching. Okay, so just remove this folder here. And one last part that I didn't show because it's not a code, but a tip. Use optimizer tools and frameworks that will help you to make a smaller container, okay? And I would like to recommend basically two here. One, of course, is Quarkus, because Quarkus, since the package part of the application will help you to have a smaller application, because Quarkus is built for that. They thought about it when they were building Quarkus. And the second part, the second recommendation is using GraalVM or Mandrill, because it's a distribution of GraalVM made by Red Hat, especially when you are building native image. I'm not going to cover native images here, but for example, this application, my container image is 400. We will try to reduce, but if we would be using native image here, this container basically would have like 20 to 30 megabytes, okay? But native image is not for any cases, for all cases, okay? You can use it, it's useful, but you should use on the right case. This is not the point here of this session, okay? But these are two recommendations for still decreasing the size of your container image. Okay. Third part, how to stay away from hard maintainability. As I said in the beginning of the session, your Docker files are still code, so you should approach to them as real code, because they are, okay? So you need to maintain that code. Okay, so third part, let me go here to this, okay, 3. So let me start here. This is where I stop in the last part. So this is our Docker file improved, or the orders are okay. We are using group units. We are removing cache. We are not installing what we don't need. How we make it even better? Boom, by using this. And what I've done here, let me create this This should be fast, I believe. Yeah, okay. What basically I'm doing here, I'm doing what I call relying on official images. Why should I do all of this if I have an official image to rely on? Okay, and I'm not saying that you are wasting your time since the beginning of the session to this point. Oh, I could start with ObjDK. Yes, maybe most of times, but I know a lot of, not that I know, but I'm working on a lot of projects that are we really needed to build our own images. Okay, if that's your case, you should follow the best practice. But if you can follow and if you can rely on the official image since the day one of your project, please do it, because inside this little guy here are a lot of good practice, best practice, patches, and whatever you need inside your image, the official image will do it for you. Okay, so this Docker file is much more easier to maintain than this Docker file. All right, I hope you agree with me. Okay, so 6 seconds, okay, that's fine. All right, so we have this guy here is a lot of improvement just by relying on the official images. So let's build a second version. How can we prove? Okay, I'm doing good, I'm using the official image. How can we prove it? Well, using tags, and should be obvious, but it's taking a lot of time here. But if you go to GitHub, okay, you don't go right now, okay, because we are in this session. But when you have time, go to GitHub and look for some Docker files, and you're gonna see a lot of this, okay. People just using from some image without tags. And what does it taking so much long? Okay, now it's done. Okay. And what's well, there are a lot of issues here. First, when you are relying on the latest version, guess what? They will sometime replace the latest version. And you will not know because you're just relying on the latest, and then suddenly your application stop working or starts doing something strange and you don't know what's happening. Well, they replaced the latest and you was not aware about it. And the behavior of the image changed because something, okay, because just something was changed. And this is very obvious, but again, if you go to GitHub, look for some examples, you will see a lot of these people don't rely on official images. Okay, and so it's something like the first part of the session about being specific. Okay, so you should be specific on whatever you are relying on. Okay, I will build from this again. And how can we prove it? Okay, we are relying on the official images. You should rely on smaller official images. Okay, so this guy here, let me compare. We build this new image. Because a lot of time, let me just list here. And I will show you some examples on the slides. Maintain 3 dump is 639 megabytes, and here 215 megabytes, more than 500 megabytes just by relying on the smallest official image. And I would like to show you some comparatives that I did here. Let me share this guy here. Here, if you start with OpenJDK, that a lot of people do, oh, just give me OpenJDK 11. Okay, you start with 628 megabytes. Okay, but you have an option to use JRE with 286 megabytes, or what I did in this application, 205 megabytes. Okay, so you save like 300 to 500 megabytes just by choosing the smallest version. Okay, if you are using OpenJDK 8, for example, you have images with 80 megabytes, okay, 70 megabytes. So you should always looking for the smallest image to start. And if you need something that is just inside a bigger image, you can move. You do the opposite, okay? So you start smaller and you go improving and growing if you need. Okay, if you don't need it, just stay on the smallest image. Let me just make a summary of this part. So how to stay away from the hard maintainability. First, use official image. So you don't, if you don't need to do all of this, please don't. Okay. Uh, be specific with tags. Okay. So instead of just using OpenJDK, go ahead and use a specific tag of the OpenJDK. And it's a bonus of sizing. Yeah, we are talking about maintainability, but when you are specific with tags, you will also help to improve sizing of your image. Choose the minimal size image wherever is possible. This and a lot of other topics of this session so far. Okay, we have the last part of the session. You will find on this blog of the official blog of Docker. Okay, as I said in the beginning, this session, this code, this slides will be is already available on my GitHub. You can go there and just find out, just to make you know that there are a lot of other contents available on this blog post. And let's talk about right now how to manage resources allocation when using Java and containers. Okay. First, okay, and this part is very important. If you are using Java 8 update 121, oops, and before, there is an issue, okay, a kind of issue, because something called C groups. And what is a C group? It's something inside of Linux called control groups that is a kernel feature of Linux systems that basically accounts and isolates CPU, memory, disk, network for usage of one or more process. So basically, a C group is a process with resources allocated for it. And what does it have to do with containers? Well, a container is based on a C group. So a container is a process. When someone asks you what is a container, you will say, well, a container is a process with resources allocated for it. So what kind of resources? CPU, memory, disk, network, and so on. And what's the problem with Java 8, 121, and before? Is that the JVM wasn't aware of this feature called C group. So when we had, by that time, until Java 8, 121, when we had a Java virtual machine inside a container, and the JVM was managing the resources, memory, CPU, and so on, it wasn't looking into the C group, in the limitations of the C group, in the limitations of the container. It was still looking into the host. Okay, so we have application. How much memory for this container? Well, 200 megabytes. The JVM was saying, I don't care. I'm looking to the host, and the host has 2 gigabytes. Keep allocating memory. Okay, so that's why we had so much out of memory and other issues until this version of JVM. So if you are stuck on application on Java 8, 121, and before, my recommendation is using this kind of hacking, maybe, built by the guys from Fabricate. This is basically a script that will help the JVM inside the container to manage all those resources allocated for that JVM for that container. Okay, so it will make this interface between the JVM and the container, this group. Okay. All right. But if you are on Java 8, 121, and Java 9, things started to improve. Okay. So basically, we have here this feature, this new feature that helps to limit the CPU usage of a container. And we have here another flag to help the JVM using the cgroup limits, okay, not anymore the host limits to calculate memory and defaults. And we have also a new flag to use a fraction of the run of the memory, the RAM memory, and not the number anymore. So it's not 200 megabytes, 300 megabytes. No, it's a half of the memory available. Okay, so it's easier to manage if you have this way. For Java 8, 191, and Java 10, uh, those flags were deprecated, and we had these three, yeah, three new flags here. Initial RAM percentage, max, and minimal. Basically, a new way to calculate the amount of memory that JVM can allocate for that process. Okay, so now looking really to the container, not to the host anymore, and allocating the memory on the heap in the right way. And also a new feature implemented by GIS JDK819 to calculate the CPU allocation based on the container by default. Okay, so since this version key, Java 8, 191, and Java 10, the JVM starts to calculate the CPU allocation based on container by default. For Java 11, and Java 11 is the version that we say that you should, if you can start using Java with containers on Java 11, your life will be much more easier. Okay, if it's possible, start with 11. And here we have some new features as well. Show settings for container metrics to display the system or container configuration. Okay, this is a new feature on Java 11. This new GGK feature here to improve the calculations for hotspots, both from containers and hotspots. For Java 12 and 13, this is a tool G8 SDB to where you can use to make some analysis on JVM that has some crash. You can attach it to a process running inside containers. Okay, this is a great feature available on Java 12 and 13. And the container support for Java Flight Recorder was improved by this version as well. And the systemd slice memory was improved as well in this version. That's another feature inside the Linux, and this is very better on Java 12 and 13. And on Java 14, there is a new feature, Java Flight Record event streaming. Okay, so you can expose the data being generated by the flight recording for continuous monitoring. So, for example, imagine that you can put it inside the JVMs that are running on your cluster, a Kubernetes cluster, and as well, and you can monitor your containers by relying on the Java Flight Recording that are running inside the container. This is a great feature available since Java 14. And an incubator feature available on Java 14 that is a new packaging tool for self-contained Java applications. Okay, this can be on the future something to help to package the application for containers in a better way that we are doing right now. It's not an issue anymore, but this tool maybe will help us to make it better. Okay, so some conclusions. First, yes, Java and containers can get along. You can use Java with containers. But if you are building Docker files, and today we have some options to not build Docker files anymore. But if you are building, if you need to build, if your project will make you build Docker files, be intentional. Okay, don't just go ahead and start throwing stuff, throwing lines inside your Docker files. Okay, so be intentional, know what you are doing. It's better to start with Java 11 and beyond. But if you really need Java 8, be extra cautious. Okay, so take a lot of care about it. And to finish here, I would like to let you with this URL from Red Hat developers. Red Hat developers, it's our program here at Red Hat to help you developer to solve your problems, your daily problems. So here we create a lot of content for Java developers about microservice for Linux developers, Kubernetes containers, and so on, microservice. So there are a lot of contents focused on developers. Okay, so this URL and the QR code is here. And Jonathan, I'm available for questions if there are anyone.
Yes. So what I see is there are, well, in fact, two questions. One comes from me.
Oh, wow.
Okay. So, so you said, well, you have given us some tips about Java running inside containers, but I wanted to just to make this question in order to make things clear. So these tips only affect a Java application running inside a JVM inside a container, but a Java application compiled natively running inside a container will suffer from different issues, but not the same ones.
Okay. When we talk about the resource allocation, basically you can't do anything, okay? Because if you create a native image, that image will run what we call a subtract VM. Okay, the subtract VM is a small, really small VM that will run with your application, and all the managing of that application will be done by that subtract VM. What can you still do with your container is whatever we talk in the rest of the application, in the rest of the session, talking about image sizing, caching, maintainability. This part is still is valid, but what we talking about resource allocation, it all will be done by your subtract VM, and you don't have any. You can't improve it and can't make it worse. It will just work as it is.
Okay. So there's another question by Rafael Borja. Can you talk about preferred container quota for CPU count?
Let me get here. It's on the papa. I have this guy here on the. Blah blah blah. Well, I thought I would have put this guy on my presentation, but yeah. I put this guy here. Let me just on Java 11 here. Oops. Yes. Well, I don't know the under the hoods of the way that they did it, but basically the way that the JVM used to calculate both the containers and JVM hotspot allocation, the CPU allocation, was improved by that flag here. But how it's done, I really don't know. But I know that on Java 11 it was added, and as Java 11 it's a LTS version. I believe it's still available. But to really know, I would read. You will need to read this guy here, this feature here that was added. Okay.
Okay. And yeah, another one from Alberto Piva is, well, is packaging tool this one? I'm not sure about which this one
means.
Okay, if you can explain a bit better, Alberto, I will ask this question. And John is asking about Jeep. What do you think about Jeep, and if it improves the optimization tool?
Mhm. Well, I have been using Jib with Quarkus. There is a extension of Jib for Quarkus. It's very helpful because it's easy. You just add, when using Quarkus, for example, just add an extension, put one argument on the packaging, and your image is done. For I would say the same as I said when using the official images. If you just need the image, use it because it's very helpful. But I think it's important to have this background because on some projects, you need to put your hands on the image, you need to make some adjustments, some small tuning. So it's useful to know what's happening inside under the hood. But yes, if your application does just need the container, go ahead and use Jib. It's very useful, and I really like it.
The next question was if you use it in production. I can assure we use it. We use in production recently for an operator. But what do you think about it? Do you use it in production, Elder?
Containers?
Jib.
Oh, Jib. I never worked on a project using, but I know people using. But I myself, I didn't use it.
And yeah, this has been everything. I would like to show this comment from Ivan that resumes, that summarizes the presentation. Thank you very much. It's been a great presentation and with a lot of tips. I also attached here the link to your article talking about these Java containers. So if you want to go to that article and check the contents in a blog post, I encourage you to do it. So thank you to everyone being here. And if it's not, if there isn't any more questions, well, you have your life ahead of you. Thank you very much, and continue with this great conference. Hasta la vista.
Thank you, Jonathan. Hasta.